Hello friends, welcome back to our channel. So today our topic is free space management, and this is the most important topic in disk management chapter of the OS operating system subject. So let's go into the topic and let's see the examples and detailed explanation of this free space management today. And let's first go with the intro. The basic explanation starts with, we will be having a hard disk, right, for our systems, secondary storage, SSD or HDD, something, secondary storage device. The memory space of this hard disk is limited, right? It will be like 512 GB or something like that. So this memory space is limited. So the files which you will be having in your computer will be already occupying the memory from the secondary storage device. Like it will be divided into three sections, like local disk C, local disk D, local disk E. So after allocating spaces for all the files in the local disk C, D and E, there will be some space will be left in the hard disk, right? So how this empty space will be managed? And you are deleting any file. So after you deleted that file, this memory should be reused again by the operating system. So how this empty space or else memory which is released by some files after deletion are managed? So that will be seeing in this free space management. So first we'll go with the introduction. Hard disk space is limited. Just now as I said, the space of the hard disk is limited, okay, and the memory should be used efficiently. Since it is limited, the memory should be used efficiently. Like we have to manage the space and we have to use that memory. Operating system allocates memory space to files in the hard disk. So as we know that operating system allocates memory space to the files in the hard disk. So if you create any file, then the operating system allocates some memory for that file from the hard disk. So this is the point. Operating system allocates memory space to the files in the hard disk. Then void space. I have said, right, the space which is remaining after allocating space to all the files in the local disk C, D and E. So that space is known as void space. The space which is remaining in the hard disk after allocating memory for all the files in the system is known as void space. And again, if any file gets deleted, then the memory should also be used. If any file gets deleted, the memory which it is holding will be released, right? So we should be using that memory also. So how this void space and this memory is maintained, that phenomena is nothing but free space management. So the four most important term in this free space management is free space list. Okay, this free space list is something which keeps track of all the free disk blocks that are not allocated to any directory or file. First of all, let's see what is meant by block. While we are going with the virtual memory, we have heard this term, right? Suppose this is your memory. Memory has been divided into several blocks. Okay, memory has been divided into several blocks, several partitions, such that each and every partition is known as block. Okay, you are clear with the term block, right? Memory has been partitioned into equal parts and each part is known as block. So that is the block. So free space list is nothing but a list which keeps tracks of all the empty blocks. Suppose if this is a memory, okay, first two blocks are used, these two blocks are used for storage of any files. The rest these two blocks are empty, right? So these blocks are known as free blocks. These two blocks are known as free blocks. So this free space list will be keeping the track of all these free disk blocks. Okay, And if you create suppose this is a free space list, okay, it will be contain blocks of memory which are free, like these are not allocated to any memory, okay, these are not allocated to any file or directory, these blocks, okay. This is list, I mean free space list, free space list. Okay, let me use pen. Okay, so if you are creating any new file, then the operating system will check for empty blocks, I mean free blocks in this free space list, and if there are any free blocks tallying with the space required for this file, then it will create file, and the free blocks, and I mean let's suppose the storage of this free space list is 510 MB. The file which you are going to create will take up 10 MB. So it will check for the memory. Is this 10 MB available in the free space list or not? And if it is available, then then the operating system allocates this free blocks to create this file. Okay, 10 MB, right? So this will be updated. So minus 10 MB, 510 minus 10 gives rise to 500 MB. So this is what happens. And if you delete any file, you have created this file, right? You will delete this file. Okay, this file consists of 10 MB. Now after deleting this file, this 10 MB free space is released. So this will be added with the free space list. Okay, so the free space list is something which stores the free disk blocks that are not allocated to any directory or file. Okay, file created, then operating system search in free space list for required memory and allocates it. If file is deleted, then the space allocated to the file is added to the free space list. That's what we have discussed in the example. Okay, so now how you will maintain this free space list and how you will achieve this free space management. For this there are 4 major techniques. Let's see one by one. So free space management is achieved by 4 techniques: bit vector, also known as bitmap, linked list, grouping and counting. Okay, all these 4: bit vector or bitmap, famously called as bitmap, linked list, grouping, counting. Okay, we will be seeing what are these 4 techniques. Bit vector or bitmap, this is nothing but each block is represented as single bit. Okay, now here each and every block is represented using a single bit, either 0 or 1. 0 indicates that block is already allocated for some other file, and 1 indicates that block is free. Okay, now let us discuss in deep with an example. Okay, consider disk. Before going to that, let me specify what is mean by vector term here. Vector is nothing but single dimensioned array. Vector is nothing but single dimension array. Okay, clear? Single dimension array. So see, let's go with an example. Consider a disk with 16 blocks. Consider a disk which is having a 16 blocks of memory. And now these are block numbers. Block numbers 2, 3, 4, 5, 8, 9, 10, 11, 12, 13 are free, and 0, 1, 6, 7, 14, 15 are allocated to some file or directory. Now according to the bit vector, 0 is given to the block which is allocated, and 1 is given to the block which is free. So now let's construct this bit vector. So you are having 16 blocks, right? So you will be having an array of single dimensional array of 16 blocks. Okay, the index represents the block number, and inside it represents bits. So 0 is allocated bit, right? Allocated block, right? So for the allocated blocks, the bit should be 0. 1 is also allocated 0. 2 is free, so represented with 1. 3 is also free, 1. 4 is also free, represented with 1. 5 is also free, 1. Next 6 6 is allocated, so 0. 7 is allocated, 0. 8 is free, represent it with 1. 9 is free, represent it with 1. 10 is also free, represent it with 1. And 11 also free, 1. 12 also free block. 13 free block. 14 allocated block. 15 allocated block, 0. So this is the bitmap for the given situation. 16 blocks where 2, 3, 4, 5, 8, 9, 10, 11, 12, 13 are free blocks, and 0, 1, 6, 7, 14, 15 are allocated blocks. Allocated blocks should be represented with the bit 0, and free blocks should be represented with the bit 1. Okay, now let's proceed further. We have to calculate the block number, empty block number. First empty block number, first free block number. So there is a formula for calculating first free block number. So let me adjust this. So let's see this example of calculating first free block number. The formula used is number of bits, total number of bits into number of zero valued words plus offset of the first bit. And a word is nothing but combination of bits. So now let's see an example. There is an example of 8 bits. 8 bits. So the first non-zero bit is at 3. See, first non-zero bit 1, 2, 3. At third position there is first non-zero bit, and so offset is 3. Okay, offset equals to 3. So we have got offset of first bit. Next, number of bits. Total number of bits are 1, 2, 3, 4, 5, 6, 7, 8. 8 total number of bits. Since word contains 1 bits, instead of all zeros there are ones also. So this is this is non-zero valued. So what we want is number of zero valued words. So since this is non-zero valued word, number of non-zero valued word is 0. So first free block number is equals to number of bits, that is total number of bits 8 into number of zero valued words, that is 0, plus offset of the first non-zero bit. Offset of the first non-zero bit is 3. So 8 into 0 plus 3 gives 3. So the first free block number is 3. Okay, this is how we'll be finding first free block number. Next, we'll be seeing advantages of using this bitmap. Advantages of using this bitmap is easy to understand. Since all the thing is based on zeros and ones. If it is 0, it is allocated, and if it is 1, it's a free. And efficient method as usual, since it's a vector, right? So it's an efficient method. Disadvantages are keeping bit vector in main memory is inefficient for large disks. So now we have considered only 16 bits. So if there are many blocks of memory, then bit vector will be very large. So placing such a very large thing in the main memory is inefficient. So that's the main drawback of this bitmap. And then we will go with second method, linked list. Linked list is nothing but all the available free blocks are linked with each other, as a form in the form of chain. Each and every free block will be consisting a pointer to point to the next available free block. Okay, let's see it with the help of free figure. So again the same example. Consider a disk consisting of 16 blocks, and all these the free blocks are 3, 4, 5, 6, 9, 10, 11, 12, 13, 14. All these blocks are free blocks. So now consider a disk with 16 blocks. Draw all the blocks, and what are the free blocks here? 3. So 3 will be having a pointer to point to the next free block. So next free block is 4. So 3 will be pointing to 4. After 4, the next free block is 5. So 4 will be having a pointer to point to the 5. Okay, same the thing which we have seen in the singly linked list, right? Nothing. What you will be having? You will be having a node, and in the node we will be having a data, and another will be pointer to point to the next node, and this node will be having a pointer to point to the next node, and to store the base address of the node you will be having a head pointer, right? And the last node pointer will points to null. The same thing happens here. it will be 3 will be pointing to 4, 4 will be pointing to 5, 5 will be pointing to 6, 6 will be having a pointer which is pointing to 9, 9 will be having a pointer which is pointing to 10. Same as this happens, and the address of the first free block will be stored in the head pointer, and the last pointer will be pointing to the null. So here for 14 free block is the last free block, so it will be pointing to the null, okay, stating that it's the last free block in the disk. Okay, clear? Now let's go with the advantages of using this linked list method. External fragmentation is prevented. Fragmentation in the sense the wastage of the memory. So if you are using continuous blocks of memory, then external fragmentation occurs. Here you are not using contiguous blocks, here you are using dynamic allocation type. So external fragmentation can be prevented. So easy to expand. If consider if you have deleted some file and there is another free block occurred here, okay, so after 14 there is another free block. So how you will be expanding this? Very simple, you will be connecting this with this, and the pointer for this free block will be pointing to the null. Simple. So it is easy to expand. Next, disadvantages. Next we will be seeing disadvantages of using this linked list. Takes more time for traversing. Like see, if you want to access 11 or 14, let's suppose, you have to start from 3 to 4, 4 to 5, 6 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 13, 13 to 14. So you have to go through all these steps to visit 14. And second one, memory overhead. Like you have to store the address of the next free block, right? So you will be requiring additional memory. So that's the major disadvantages of linked list method. Now next, grouping method. Grouping method is just the modification of this linked list method, same everything, but the only difference is the first free block will be consisting of addresses of next n free blocks. Okay, let's go straightly go to the example. Here you will be getting more clarity with the example. So where is the example? Just a minute. Okay, go with this example. Free blocks. These are the free blocks: 3, 4, 5, 6, 9, 10, 11, 12, 13, 14. Okay, let n be 3. Okay, the first free block is 3. So the first free block is 3. So 3 will be containing the addresses of next n blocks. We have assumed n as 3, right? So next n blocks after 3 free blocks are 4, 5, 6. Okay, 4, 5 and 6. Okay, next these 4 and 5 are free blocks, but 6 contains addresses of next 3 free blocks: 9, 10, 11. Okay, 9, 10 and 11. These two are free blocks. 11 will be containing addresses of next 3 free blocks: 12, 13, 14. Okay, now 11 will be consisting 12, 13 and 14. These two are free blocks and this will be pointing to the null. Clear? So each and every first free block stores addresses of n free blocks, in which n minus 1 are free blocks, and the nth block will be consisting of next n addresses of next n blocks. See, we have started with 3. 3 will be consisting of addresses of 4, 5 and 6. 6 will be consisting of addresses of 9, 10 and 11. 11 will be consisting the addresses of 12, 13 and 14. Out of these, 6, 11 and 14 and 3 are used for storing addresses. Okay, storing addresses. The empty things, the free blocks are 4, 5, 9, 10, 12 and 13. All these have been used, all 3, 6, 11, 14 are used for storing addresses. Okay, clear? Now let's see advantages and disadvantages of this. See, instead of diagrammatic way, I have represented as this. Block 3 will be consisting of 4, 5 addresses of block 4, block 5, block 6. Block 6 will be containing the addresses of block 9, block 10 and block 11. And block 11 will be consisting the addresses of block 12, block 13 and block 14. Now let's see the advantages of using this. Addresses of large number of free blocks can be found quickly and easily. So if you want the address of 10 free block 10, you have to search only with the block 3. You have to search with the block 3, you will not get. Next you have to search only with the block 6, then you will be getting easily. Instead in the linked list method, you have to start from 3 and traverse up to 10. So it will be a hectic task to traversing each and every block to get into the required target block. So address of large number of free blocks can be found easily. Okay. No need to traverse the whole list. Like I have explained, you no need to traverse from the starting of the list. Disadvantages of spaces of one block wasted for storing addresses. I have mentioned here, right? Block 3 and block 3, block 6, block 11 and block 14 are used for storing addresses. So these free blocks are wasted. So the fourth method is counting method. Counting method also is a modification of the linked list method. This method will be consisting of each free block consists of pointer to the next free block as it is in the linked list type. And another thing is the count of free contiguous blocks after it. Okay, the count of free contiguous blocks after it. Like see from this example, same. The disk will be containing 16 variable. Disk will be containing 16 blocks. Block 3, 4, 5, 6, 9, 10, 11, 12, 13, 14 are free blocks. Okay. So 3. Let's start from 3. 3 will be pointing to 4 and 3 will be containing count of next how many contiguous blocks of free blocks are there after 3. Contiguous means in the continuous manner. Like see 4, 5, 6. 3 has 3 contiguous blocks of free blocks after it. Next, see, after, let's go with 9. Okay, 9 will be pointing to 10 and 9 will be storing the count of contiguous blocks after 9. Count the contiguous blocks: 10, 11, 12, 13, 14. 1, 2, 3, 4, 5. So 5 blocks. 9 will be storing a value of 5. Okay, that's the count. Okay. See, these are the empty block numbers, and block 3 will be consisting of the count 3. After 3, 4, 5, 6 are contiguous blocks. Contiguous are nothing but continuous. Like in between there are no allocated blocks, only free blocks at a stretch. So 4, 5, 6 are contiguous blocks after 3. So 1, 2, 3. Block 3 will be storing a count of 3. And as usual it will be pointing to the 4. In addition to that, it will be storing this count value. And block 9, after block 9, 10, 11, 12, 13, 14 are contiguous free blocks. 1, 2, 3, 4, 5. So 9 will be pointing to 10 and storing the contiguous value of count of 5. Okay, clear. Now let's see the advantages of counting. Advantages of counting are faster allocation of large number of consecutive free blocks. Like if a file requires only contiguous blocks of memory, using this counting approach, we can find the contiguous blocks of memory easily since we are having count here. Okay. Disadvantage: each block requires more space to store the count. As I have said, now if there is any node now, it in addition to the pointer, it should be storing the count variable also. So you will be needing the count variable in addition to the pointer variable. So you will be requiring more memory to store this count variable. So that's the disadvantage of using this counting method. So this is how you will be using the free space management. So the main motive of the free space management technique is to use the space available in the hard disk efficiently in an efficient manner, and so that if memory management is efficient, each and everything will be efficient. Allocation, deallocation, everything. So this is about free management technique, free space management, and in the next video we will be seeing how this file is allocated, how the memory will be allocated to the files. So okay, and that's it for the video. Thank you guys.